You know that little padlock icon you see up in your browser's address bar? It's easy to take for granted, but it's the sign of a secure, encrypted connection. But here's the thing. Just a few years ago, the internet was a fundamentally insecure place. Today, we're going to tell the story of the single, brilliant protocol that completely changed web security for all of us. It is wild to think about now, but back in 2015, most of the web was just wide open, operating in plain text. So every time you logged into a site, sent a message, did pretty much anything, without that padlock, your data was just flying across the internet, totally exposed. Anyone with a little know-how could just read it. And this chart really puts the scale of the problem into perspective. In 2015, only about 40% of website visits were encrypted with HTTPS. That means a shocking 60% of the time, the web was basically an open book.
But let's fast forward to today, and the whole picture has flipped. The default state of the web is now security. Encryption isn't the exception anymore, it's pretty much the rule.
And just look at this updated chart. I mean, wow. From just 40% in 2015, we've skyrocketed to nearly 95% of US website visits being encrypted today. That is a massive shift in the fundamental safety of the internet, and it happened in less than a decade. The big takeaway here is so important. When you remove the friction, in this case, the cost and the complexity, you can drive incredible industry-wide change. So how on earth did this happen? How did this massive, decentralized, global network manage to fix one of its biggest and most dangerous security problems so quickly? Well, the answer is a fantastic story about collaboration, a couple of nonprofits, and one really clever protocol. Okay, so to really get the solution, we first need to dive into the problem. Why was the web so insecure for so long in the first place? J.C. Jones, one of the architects behind the solution, really hits the nail on the head here. The problem wasn't that people didn't want to be secure. Of course they did. The real stumbling block, the thing holding everyone back, was that getting and managing these security certificates was complicated. It was expensive, and it was a totally manual process. That was the bottleneck.
So, this problem sparked an idea that would change everything. Back in 2013, a group of collaborators from places like Mozilla and the Electronic Frontier Foundation, they all got together with this radical goal. Let's create a new certificate authority that's free, automated, and open to absolutely everyone. And they called it Let's Encrypt.
And this insight from Aaron Gable, a tech lead on the project, is absolutely key. Automation wasn't just a nice feature to have. For a small nonprofit team with the mission to secure the entire internet, it was the only way they could possibly operate. It was either automate or go home.
And that automation has a name, ACME. It stands for Automated Certificate Management Environment. This protocol is the real hero of our story. It's basically a set of rules that lets a computer program automatically prove it controls a website, and in return, automatically get a security certificate. No humans required. So how does this automation engine actually work? It's surprisingly elegant, actually. Let's break it down.
Okay, imagine your web server wants a certificate. First, its software sends a request. The certificate authority server then says, "Okay, prove it," and gives it a unique challenge, like asking it to place a specific file at a specific web address. Your server completes that challenge, proving it has control. The authority verifies that the file is there, and boom, a certificate is issued. All of this happens in seconds, without a human ever lifting a finger.
Now, this is a super important distinction to make. ACME doesn't care who legally owns a domain name. It only cares about proving who controls it at that exact moment. By focusing on control instead of ownership, it could completely automate a process that used to involve things like paperwork and manual checks. This one simple shift in focus was the key that unlocked its incredible speed and scale. So, what was the real-world impact of making security certificates free and automatic? Well, the numbers really do speak for themselves.
Today, Let's Encrypt has issued over 700 million active certificates. Just think about that. A single nonprofit is responsible for securing the majority of the entire public web. The scale is just staggering. And ACME's influence didn't just stop with Let's Encrypt. Because it was built as an open standard, by 2019, it became an official internet standard adopted by the Internet Engineering Task Force. This standardization lets the entire industry move towards more secure practices, like shorter-lived certificates, something that would be impossible without automation. The point is, an open standard allows everyone to build a safer web together. But the story isn't over. Not even close.
ACME was designed to be extensible, and its evolution is continuing to push web security forward.
Engineers are already working on cool new features, like more flexible certificates and new ways to prove you possess a cryptographic key. But the most exciting part might be that last point, using this same challenge and response idea to certify the identity of physical devices, not just websites. Imagine securing everything from your smart thermostat to critical industrial sensors. The really crucial takeaway is this. ACME didn't just fix a technical problem. It proved that a small, focused team working out in the open and prioritizing automation can solve a massive, global-scale issue for the common good. It fundamentally helped fix the web. And it kind of makes you wonder, what other huge problems could we solve the exact same way?